Part of the graph of y equals 4 sine x degrees minus 3 is shown below. The graph cuts the x-axis at Q and R. P is the maximum turning point. Firstly, write down the coordinates of P. But we know that the sine wave peaks at a value of 90 degrees, so we can work out this. So 4 sine 90 degrees minus 3. So what's that equal to? Well, sine of 90 degrees is equal to 1. 4 times 1 is 4, so 4 minus 3 equals 1. So the coordinates of the peak are 90 degrees, 1. So that's our answer to A. Now part B, calculate the x-coordinates of Q and R. So Q is here and R is here. We want to solve that. So we need to set y equals 4 sine x degrees minus 3 to 0. So that equals 0. We can solve that then. So rearranging that equation a little bit, if we add 3 to both sides, we end up with 4 sine x degrees equals 3. Then we want to get rid of the 4, so we divide both sides by 4, we end up with sine x degrees equals 3/4, or 0.75. Then we want to get the value of the angle, so we use inverse sine. So on your calculator, that's sine to the minus 1, 0.75. So that gives us an angle of 48.6 degrees. So that's our first solution. So that's the answer for Q. We need to find the second solution now. So we draw a diagram that helps us see what's going on. So there's our 48.6 degrees. That's our first solution. So where else do we get an answer that's positive for sine? Well, remember cast. So all sine, tan, cos. So our second solution is going to be in the second quadrant, and it's symmetrical. So our answer is going to be here. So it's going to be 180 degrees minus 48.6 degrees. So 180 degrees minus 48.6 degrees. And that equals 131.4 degrees. So that's our second solution. That's the value for R. So 48.6 degrees and 131.4 degrees